Okay, so as you know, this is the MS Electrical and Computer Engineering, Machine Learning and Data Science degree that we're talking about today. And Professor Chugg already introduced me. And of course, Professor Chugg is the Associate Chair of our department. And in that capacity, he oversees all the academic programs in the department, including this master's program. Okay, first, a little bit of history and motivation. If we pick just one financially crucial resource to characterize each century, I'm going to go back to the 19th century first. One could argue about this, but most likely, most people would say gold is probably the most financially crucial resource or commodity of the 19th century. So I won't say much more about that. What do you think it is for the 20th century? Any comments among the students? I just realized I cannot see the chat comments the way I'm set up right now.
Somebody said steel.
I think
Steel?
it's electricity.
Electricity, okay. These are possibilities.
Oil.
Oil, okay. Yes, I would say oil, and I think most people would agree with that. It was really the century of oil.
You can use it to make steel and electricity, some type of petroleum energy source.
Yes, absolutely, oil. We now may be entering the realm of declining oil, but I want to make a couple of comments about this before we go on to the 21st century. Oil by itself isn't necessarily all that useful as it comes out of the ground, but what has happened is it's found so many different uses because of enabling technologies. And examples of enabling technologies would be refineries, being able to refine oil into gasoline or diesel for car or truck transportation, or jet fuel for air transportation. So it has a lot of the transportation sector, of course, relies on oil. Then we have power plants that generate electricity from oil. So there we get electricity because of the enabling technology of power plants, et cetera. And one could come up with a lot more, of course, for oil, such as making plastics and other things. So here's a question for you. What do you think it's going to be for the 21st century? And so we'll open this up to students as well. And maybe Keith or someone can help me out since I can't see the chat comments that come in. Any ideas?
Yeah, we have someone who said data. We have another student who preemptively said data before.
Okay,
the 20th century.
Okay, well, in fact, many people are saying that data is going to be the crucial resource or commodity of the 21st century. And so I have that here as the next one, data. And one example of a source for that is The Economist, which in May 2017 had an article saying that the world's most valuable resource is no longer oil, but data. And there are many other sources too that are saying it looks like data is going to be a really big deal for the next, at least the next 2 or 3 decades. So there we have it, perhaps the century of data we're in now. But it's kind of like oil in that data itself isn't necessarily very useful. What we need is enabling technologies to make use of it, convert it into something that's really useful for people or for other applications. And what do you think that is? Well, machine learning and data science is a big part of that. In fact, if you think about electrical and computer engineering, essentially all the topics in ECE help to use data in some way. Communications, we'll move it around from one place to another. Signal processing changes its form into something that's more useful for people, et cetera. And clearly machine learning and data science are really just made to take in data, change it into a way that really helps people or helps things. And so there we have that as an enabling technology. Okay, so now next, why do we have this MS ECE Machine Learning and Data Science specialization degree? And I just have a few brief points on this. One is it defines a cohesive and complete set of courses to provide breadth and depth in the degree. Now, the fact is, you could do everything that's in this degree, you could do as just a standard MS ECE degree, and you're welcome to do that if you prefer. But having the MLDS there on your degree says that this degree is specifically oriented towards this, and it's a set of courses that give you sufficient breadth and depth in machine learning data science. It's also intended to prepare you to excel in future positions in industry or academia. And we've really spent some time designing this degree to do just that. As I already mentioned, it's explicitly focused on these topics. And finally, it's intended to be a premier master's program in ECE. We really want this to be a big, high level, and we want graduates that graduate from this program to really know the material well and to get good positions in industry and do really well in their future careers. Okay, so on to the particulars of the actual degree and their requirements. So here are 4 key components that go into this degree. And I'll add, as I go through this, if you have questions or comments, feel free to just unmute and say them out loud or type in the chat, and the other keys will notify me of what's coming in. Okay, so we have a few things here. First, we have a rigorous background, which is really crucial, not only for you to do well and understand what's going on in the more advanced courses, but in your career to be able to continue to improve and excel and make progress. So we have probability, linear algebra, and digital signal processing there. Similarly, we have a software, which also is a background and something that's really crucial for you to know to really do well in machine learning and data science. And we're talking about software knowledge of different realms in which you need to use software, and software skills being actually able to do it and do it well and reasonably efficiently. Okay, then over on the left, we have machine learning itself, including data science. And up here we have machine learning core. So we have a set of core courses which are crucial to machine learning and data science in particular. And this emphasizes theory, understanding, and methods. And the idea here is we don't want you to just know a bunch of methods you can apply and get some numbers out. We want you to understand what's going on, what methods will work, and how to use them best, how to interpret the results, and how to know whether the results actually are giving something useful, or whether you're just getting lucky with the particular data set you have. So that's the theory and understanding parts of that. And down here we have machine learning application. And so here, we're looking at 2 different things. One is domain knowledge. If you're interested in a particular application domain, it might be speech recognition, it might be medical imaging, or any of the plethora of other realms. We have many courses available for you to take to learn about that application and apply machine learning to it. And then also practical experience. In your courses, you get quite a bit of projects, doing coding, solving machine learning problems to get some practical experience. And of course, there's also the option of the internships to get you some experience in industry during your degree program as well. Okay, so that's the introduction. So now I'm going to move on to the actual degree requirements. And it's on the internet, and here's a link for it. And I already have it open, so I'm going to now switch. I might have to change the screen share when I do this. Some of my keys just are not doing what I want them to do. I don't know why. And I don't want to get to that yet. Oh, here we go. Okay, so now I'm going to, I guess I need to change my screen share, which I can do up here to here. Okay, so this is a web page. So you have access to this at any time. So let's go through this basically. The total number of units is 28, and we'll talk more about what they need to be right down here. So we have a few categories of classes. First, required foundational proficiency. You really need to be proficient in digital signal processing at the level of EE 483. And if you are, you're welcome to test out of that. And if you're not, we have a course just for that, EE 483, which you then would be required to take. And that's 4 units. Okay, then foundations. This is what mentioned on the previous slide, 503 probability and 510 linear algebra. And these are 500 level classes, so they're likely more material and perhaps deeper than you got as an undergraduate, which is why you're required to take them here rather than having the option of testing out of them. Then we have software courses. And I didn't mention on the previous slide, but that software component is a really important component in EE, because that's one area that graduates from EE and EECE tend to be weak on relative to what employers, companies really would like to see in people they hire for machine learning and data science positions. So we have an emphasis on software in this degree program, and you're required to take at least one of these 4-unit classes, and you'll also use quite a bit of software tools in some of these other classes that you'll get after that. Okay, then learning and data analytics. This is the machine learning core we were talking about. You're required to take at least 2 courses out of this list of 4. And as you can see, these are all essentially machine learning.
Sorry to interrupt, but can others see? It looks like your screen share is stuck. Like you're not showing soft.
Oh yeah, actually it doesn't give me the green border on the window anymore. What happened?
You might have to stop and restart it.
Yeah, I'll stop it and restart it. Yeah, that's a good idea.
In the meantime, if you guys check chat, I pasted the link for what Professor Jenkins is sharing, so you can open that and peruse it in parallel.
Oh, good. Here we go. I see. Okay, you've got this whole screen now. That's fine. All right, let me do this.
So in the current version of the degree, the software courses, you have to take 1 class out of CS 402 operating systems, which many of you know is, I think, a class where you'll learn a lot of C. EE 455, Introduction to Programming Systems Design. That's C++ or Java now. It's an object-oriented class. Or you could take EE 595, which is usually taught by Professor Shaheen, Software Design and Optimization, which is based on, I believe, on C++ or C, and involves things like multi-threading, mutex, that kind of more low-level details than you typically see in like 455. Sorry, go ahead, Keith.
Yeah, thanks, Keith. That's great. Okay, so now I think I've got it shared so everyone can see it.
Yep.
Okay, so yeah, so we think the software aspect is very important, and that was a good brief discussion of each of those. So next category is learning and data analytics. And so here we have 4 classes, which you can see are all very machine learning, data science oriented, and you're required to take at least 2 of those. And then finally, technical electives. And by the way, these were, as I mentioned earlier, before the screen was shared properly, these will go into the core machine learning circle we had on the previous slide. And then the technical electives give you a lot more options. You can take more software classes. You can take application-specific classes and application domains to get more domain knowledge. You can go deeper into some of the theory behind machine learning and data science. You can go into some communications realms, other signal processing realms, etc. So that's largely up to you. And also, as part of the electives, you can take one or both of the courses here in learning and data analytics that you didn't get. You can take an additional of these software courses if you like as part of your technical elective. And then finally, research. You can apply some directed research or master's thesis to the degree, a maximum of 4 units. and you once you get up to 28 units satisfying all those requirements, then you're done. And we do encourage internships as well. It's really good to do those in the summer, but any units on internships won't count towards the 28 units that you need from classwork towards a degree. So before I go on to the next topic, are there any, you have any questions on the requirements here?
Hi, can you hear me? I have a question.
Yeah, I can hear you.
Hi, I have a question for the technical selective. So, so if I want to take a EE class, which is not listed here, so can I still take that as a part of the degree requirement?
The general answer is no. Now, if there are good specific reasons to apply that as a technical elective, you can fill in a request to ask that, and we'll look it over, and if it's appropriate, we will approve it. But we did go through all the courses, and these are pretty much all the ones we think are appropriate. Now, a particular case where there are definitely going to be exceptions are EE 599s, since those are new classes. So if there's an EE 599 that's particularly appropriate, there's a good chance we will approve that. And an example is EE 599 deep learning with which Professor Chugg created and has been taught twice, and now it's being taught this semester for the third time. That can qualify as a technical elective. And it's obviously, deep learning is clearly in this topic area. So that's one that we would allow to be applied. So feel free to apply for exceptions for EE 599. For other classes, you can apply, but chances aren't good unless it's very clearly related to the degree.
So somebody, so what, out of curiosity, which class were you, is it a general question, or you have a specific question in a specific class in mind that you were thinking?
Yeah, I do have a specific class, which is EE 451, so which is called Parallel and Distributed Computing. So I think it's related to what I want to study is part of the data science area.
Yeah, I mean, we have to consider that, and this degree program is fairly new and it's evolving, so we're going to be making changes to it. And personally, I think that class would be a reasonable class, because you're learning some CUDA programming in that class. I believe some distributed cluster computational methods and things like that. So I would think it would be a reasonable course to consider, but it would have to be approved through Professor Jenkins.
Okay, thank you very much.
I have a quick question.
Sure.
Is this going to be available for PDP students? Like, would these course credits change at all, or is this strictly the 20, I believe, 9 units master degree?
Well, that's a very good question that we haven't addressed yet. As it stands now, it's not available to PDP. I mean, you would need to satisfy the full 28 units as described here, but that's something that we can take into consideration and see if it makes sense, see if we can come up with a way of doing that. That's a very good question.
Awesome, thank you.
Yeah, I mean, if you were our own undergraduate student, you would have to kind of know, if you wanted to not do a PDP, but do this in some way, like 483 is a class you could take as an undergrad, and that would be still is a requirement for this program. And then sometimes you get students that will take, say, 503 instead of 364. And so there potentially you could do those two classes as, part of your bachelor's and master's. But yeah,
Okay.
we haven't really considered it yet. That's why in chat I said we'll talk about it, because I didn't know the answer.
Sounds good.
Given the degree, the unit class, the unit count, it's difficult.
Cool, thank you guys.
Sure. There's
Okay, well, I think
questions in chat, Keith. I don't know if you want to take them now, or you want to.
why don't we move on and finish? I've got a couple more slides, and then we'll have and then if Keith, if you want to say a few things, you can, and then we'll have the remaining time for more questions and answers. We can
Okay.
Address them then.
Yeah. So
I
for those of you that are asking questions in chat, we see you, but we're going to hold off on answering them for a couple more minutes, as Professor Jenkins mentioned.
All right, so go back to the keynote presentation here. Okay, so the next issue is if you want to change, if you're currently in a different master's program in EE or ECE, and you want to change to this machine learning and data science master's degree, you can. This is what's required and how you can do it. First, you need to currently be enrolled in some MS program in the ECE department. And if you're outside that department, there might be additional requirements to what's listed here. You need to have some multivariate calculus in your background. You must have taken at least 2 of these 3 foundation courses, 483, 503, and 510, and have a minimum a GPA on those 2 courses of 3.5. You must also have an overall minimum GPA of 3.5. And then once you're in this degree, you must meet all the requirements of this degree without substitution. So if you've already taken 2 or 3 other classes that don't qualify, you might end up taking more than 28 units. You wouldn't have taken more than 28 units to finish the degree. And the procedure, if you want to do this, is not difficult. You just meet with an ECE academic advisor, and they'll have you complete a change of major form. But they'll require you to wait until you get till you complete the 2 of these 3 foundation courses and have your grades posted officially before they'll let you fill out that form and get it approved. And then you're in. Okay, and then the final thing I want to mention is that as Professor Chugg mentioned, this degree program is new and it's evolving. We've already made some plans to change it and we think improve it. And then it'll be a new set of requirements, not a lot different than the current set, but somewhat different. And that degree program will start in the fall of 2021. I'm going to give you highlights of what that program is and how it differs from the current degree program. And if you want to, if you prefer to take the master's degree into that program, you can, if you'll still be here for the next academic year, as long as you meet all the requirements of that new program. So just so you're aware of what's coming, I want to tell you a little bit about it now, because this you won't find on our website yet. So we'll go to the next slide. So as long as you enroll in the program in fall 2021 or after, you're fine. So you could, if you're starting this semester, for example, wait until fall 2021 to enroll in this program if you want to get it under the new requirements, and take appropriate classes this year so that they will qualify. And that's what the second bullet's about. Another thing is if you're already in the program now and you want to change to the new one in the fall, I believe that it will be possible too. I should mention that what I'm going to tell you about, they're not quite final. They're pretty close to final, but there might be slight changes between now and when they're finalized. They're still going through approvals at different levels of the university at this stage. Okay, so here's an overview, this slide and the next one, of the current program and the future master's program that starts next fall. Foundational proficiency will include 483 as it does currently, and you can pass out of that, but we're adding another course, EE 547A, Computing Principles for Electrical Engineers. And let me explain the background behind this. The current program has, for software, you take 1 4-unit course, you can pick any one of these 3. We did a hard look at what is in these courses, what's in computer science courses that are appropriate for software for this program, and what employers really want to see students have and what students seem to need once they get farther into their careers, and put it all into 4 units worth of classes. But instead of 1 4-unit class, we made it 2 2-unit classes. So we have the first 2 units here, EE 547A, and then we have the second 2-unit class here, EE 547B. And those 2 combined, first A, then B, will be the 4-unit class I was just talking about. And that's a good, a fast pass through pretty much all the topics we think you'll need, although not as much depth as if you took 3 or 4 different computer science courses, which is what you would need to take to cover all that material. So Keith, do you want to make any other comments about these 2 classes before I move on? I guess not.
That's pretty good. I think just 547A is really, so for example, some of you may even be enrolled in the current 599 class by Harash. I don't know the exact title, Computing Principles or something like that. That's essentially the 547A. So that's really going to be an object-oriented programming language like C++. And it's going to cover like data structures, algorithms, you know, complexity a little bit. So it's a little bit like CS570 combined with, say, EE455. So you're going to do some programming, but also, and some of the data structure classes that you may get in CS. And then 547B is more back-end or application-specific, you know, software design. So things like Docker, Kubernetes, virtualization, some front-end design, so you can build an app, a web app with a back-end server, essentially. So they're, you know, the goal is, like Professor Jenkins said, we're not going to give you, you know, 12 units of programming in CS, and many of you don't have the background to directly take those CS classes, but we're sort of pulling out what we think is most useful in practice for you as you go out and search to get a job. So and they're also they're very much designed for people who are in this program and who have a background more in systems, EE systems, than they do in, say, in computer science.
Yeah.
Yeah, so just one other thing is somebody's asking if you already take 599 computing principles for EEs this semester, then that would count towards the credit for degree credit for 547A. So that would be, they're similar enough that would count as your placement for that.
Okay. Yes, good. All right, so 547A is part of our foundational proficiency. It's even possible to pass out of that test if you've had that material already in your background and you can prove it. So then we move on to okay, so that takes care of the software and all the foundations. Well, the first foundational proficiency in the current program, structured a little bit differently in the future program. Now foundations is a little bit lumped, we have things lumped together a bit differently in the new program. We've got the 503 and 510, so they're both still required just as before, but now we've also put these other classes into foundations instead of calling them core classes. So we have, okay, here's the next set of two new classes. As most of you probably know, we've had the CE 599 deep learning class, which is now being taught for the third time this semester. And it's been, I'm speaking approximately here, divided up into two unit classes. The first one is EE 541, Computational Introduction to Deep Learning. And the second one we'll see on the next page is EE 641. I think it's called Deep Learning Systems. And so that they don't have to be taken in the same semester. In fact, they can't be. I think one's a prerequisite for the next. And Keith, do you want to make any comments about those two?
Sure. So, you know, we've offered this class, as Professor Jenkins mentioned, 3 times: spring 2019, spring 2020, and currently Professor Fransky is offering it in fall. The roughly speaking, that class is both a combination of theory and a lot of hands-on work. So I would say there's kind of 3 areas that are taught in that class. One is sort of the mechanics. So we have students who come in and maybe they don't know Python, or they have very limited exposure to Python. So we get them up to speed on Python. Similarly, we have students who come in and they're not very comfortable working on the Linux command line. They've never been on an AWS machine. They've never used a GPU to train something. So all of those are mechanics that we bring you up to speed on. You know, learning TensorFlow and a little bit of PyTorch. All of that I put in this mechanics area. The other is sort of core background theory, which is taking your background in 510 and 503 and teaching you about machine learning background and concepts that we use in deep learning, but are more generally applied to machine learning. And then the third is the core deep learning theory and concepts, different types, convolutional neural networks, recurrent networks, a little bit of natural language processing, all of these ideas that are very specific to deep learning. And so one of the challenges that we've had is that we made the prereqs 503 and 510. And in the second topic, where I'm covering sort of the background theory, it was very rushed, and it's basically duplicating a lot of the 559 class. And so what we've decided to do was split it into two 2-unit classes, where the first 2-unit class, which is called 541, you could take that in parallel to 503 and 510. There's no prerequisites. And that's going to have the mechanics. So when you come out of that class, you would kind of be up to speed on Python. You'd know how to train something on a GPU in the cloud, and you know how to use PyTorch and TensorFlow, and maybe not understand all the details of the theory, but know how to do some training runs. And with that knowledge, you could use neural networks as example solutions for other classes in the deep learning track. And then after you take, ideally after you take 541, you would take 559, which would cover that core machine learning theory. And then after 559, you take the second half of the class. I should mention that the other component of the Deep Learning 599 was a fairly detailed project that the students defined. And so that moves into the second component, the second 2-unit class, the 641 class as well. And in our program here, 541 is a requirement. So everybody in the program will have that, minimum proficiency in Python, Linux, cloud computing. And the 641 is not a requirement. It's an elective. 559 is a requirement. So that's kind of an overview of why we did it, and hopefully it will work well that way.
Yes. Okay, and then the other thing we have here is EE559, which as a course is not new. However, it's going to be upgraded from 3 units to 4 units. And it will include other aspects of machine learning in addition to the mathematical pattern recognition. And so it has a new title, Machine Learning 1, Supervised Methods is 4 units. And that'll be starting actually this spring, next semester. It'll be taught as a 4-unit, the new 4-unit version, even though I think in the catalog it'll still list it as the old 3-unit version. And so that's now become a requirement rather than one of the pick 2 out of 4 that we had over here that we're going to see on the next slide, I think. But we did, maybe I missed that. Let's see. Yeah, no, it's here. Okay, so here we have learning and data analytics for the current degree program. You pick 2 of these 4 that we already saw on the web page when we were looking at that. Now the future program has learning and data analytics. These are not all required. It's similarly, you take 2 of them. Now you will have already taken 559 because it's required in the new program. But you have the other classes, 500 and 588 to choose from, and also 660, which is also being upgraded to 4 units starting fall 2021. It'll be called Machine Learning 2, Mathematical Foundations and Methods. It'll include, between EE559 and EE660, all that material will be included in the new versions of those 2 classes, but EE660 will have additional topics in it. That in machine learning that have become a lot more prominent and are likely to grow in the future relative to when the EE660 was first created back in 2014. And this was already alluded to, the other 2-unit class for deep learning. So the EE541 was required, and now, as Professor Chegg mentioned, this is not required, but it's one of the 4 in this learning and data analytics, which you have to take 2 of. And so that's an option for you to take as well. So there you get the more advanced deep learning and a major project as well. And then finally, we have both have technical electives, which I didn't bother to list here because there's so many, but they're on the website that we were just looking at. I think we've added 1 or 2 courses for the new future program, but otherwise it's the same list. Another key difference, though, we're upping the amount of units required from 28 to 32 for the new degree program. And that's because to take all these courses we think are crucial and give you at least a little bit of room for choosing some courses you want and maybe an application area you're interested in. We really need to be 32 units to give you a full program. So that's an overview of what's to come. And you're basically you're in a very good position this semester if you're starting out now. You have a choice. You can do the current program, and you can be here for 2 years to finish it, no problem. Even if it takes you 3, hopefully it won't. Most students are done in 2. But even if it does, it's no problem. You'll be under the current rules, the 28 units, and all the requirements that are already in the catalog and on the website. You also have the choice of come fall 2021 to switch to the new program, as long as you meet the entrance requirements and do everything under the new rules. And if you think you want to do that, keep in mind when you select courses this semester and in the spring that they're as much along the lines of the new program as they can be. So that's all I was going to say. So I'll just, at this point, I think I'll be quiet, and if Professor Chugg has any more comments, he might want to make them, and we'll open it up also to questions and answers, questions that you might have, and hopefully we can answer them. So I'll stop my screen share now.
I just wanted to mention that there are a couple of people asking what's the difference between this and the CS master's program, data sciences. And I'd say the main difference is this is for an ECE student and CS is primarily for a CS student. I don't know the details, but in CS, they have these degree programs if you're not a CS undergrad that requires taking, I think, 36 or 38 units. So you can get up to speed on CS background material. So one is that we expect most of the students coming into this program will have a background in ECE, typical background like signals and systems, classes and those sorts of things. And I think our program is more in the vein of ECE. It's more grounded in the mathematics. So like in CS, you can take 567 without having had a class like 503 or 510. So here we're requiring that you have this very solid background in the foundational mathematics. And the other big component is that we have a requirement of, say, a 483, which is a DSP, signal processing class. So we view, machine learning as, in the context of electrical engineering as an important component of this degree program. So many of you probably think you want to study machine learning, and then the only place you can work is Amazon, Google, Facebook. But in reality, this is a tool, and traditional companies that would hire ECEs that know signal processing or controls or communications are looking to hire people who have electrical engineering backgrounds, but also have knowledge and practical knowledge in machine learning. So that's the kind of position that I think this degree puts you in. And what we found was that, even though we were producing students that may know the math a little bit better, they were not quite as strong in the software component. And a lot of the employers, when they interview, before they'll interview you, they might give you a software test up front. And so you have to get through that. And that's part of, replacing a generic 4-unit C programming class with these 2 2-unit classes that are really targeted to bring somebody up to speed with an ECE undergrad to hands-on experience working in this field. You definitely, so somebody's asking, they took 559 and 660 already or are completing them. And they're asking, if they want to get in this program, do they have to take it again? Which definitely don't take it again. That would not make any sense. Yeah. But the question is, I guess you could do the current degree program as is, but if you wanted to do the new degree program, these are questions that Professor Jenkins is really in charge of figuring out, but you can answer, Keith. I would imagine there's some accommodation we can make in that case where.
Yeah, that's a good question that we haven't thought of before. So yeah, that's something we'd have to look at and decide. I think we'd probably allow that and say sure. And
So
actually,
it might come down to the unit count too. It might be you take those two and then you take deep learning A or something, and that gives you an additional 2 units, so that you have the equivalent of the 8 units you would have under the new 559 and 660, something like that.
yes, yes. And actually, I think I know the answer to this question as well, and it's just what Professor Chugg was saying, basically. Because the course numbers are not changing in the university system, if you've taken EE 559 and EE 660, you've automatically satisfied those requirements for the new version of the degree. But you'll still need the 32 units, and those 2 classes only gave you 6. So you have to supplement them with a couple more units to, in effect, be equivalent to the new 559 and the new 660, but you won't need to take them again. And in fact, if you were to take them again, you would not get credit. How does that work?
Yeah.
You would only get credit for one of the 2. You take EE 559 twice, it only counts as if you took it once, but I'm not sure whether it would count as 3 units or 4 units in the system. But anyway, yeah, as Professor Chugg said, that's not a smart way to go. So yeah, don't take them again.
So the biggest change in the evolution, the new program that we hope will be approved and start in fall of 2021, is that it's a 32 unit degree program now. So it requires more units than the standard master's degree. And our intent is to produce students, get very good students in and produce students out that have very solid theoretical background, but also very good with the practical hands-on work, working with data and with their software skills, so they get good job placement. And our hope is this will have a separate admission process for incoming students in the future. So our goal is to build a program that's selective and sought after by both students and employers. Somebody asked, what's the difference between CS 567 and 559?
Okay, yes, I get this a lot. And I guess let me answer in terms of the new EE 559, because starting the next semester, that will be taught in the new version, the new 4-unit version. If you look over the topics, say in the syllabus of each, you would see some difference, but you wouldn't see a lot of difference. My guess is it depends on who's teaching the 567. My guess is you'd see at least 50 or 60% overlap in the topics, and maybe more. So both myself and Professor Shaw in computer science strongly recommend that students do not take both, because you're wasting some of your units and some of your time. That having been said, I think there's also a difference in philosophy of the 2, although I have not verified this with the last 2 or 3 years of teaching of CSCI 567. But typically the computer science courses versus similar EE courses are a bit different in that EE tends to emphasize the theory and understanding of what's going on somewhat more than the coding and getting things working aspect of it. So that's another difference probably, but I know from the most recent syllabi I've seen in CSCI 567, they say up front that they're emphasizing more theory and understanding. So maybe they're less different than they used to be on that regard too. But in any case, for this degree, you need EE 559, and you do not, and CSCI 567 will not get you any credit towards this degree, just because there's so much overlap.
Yeah, so somebody asked if there will be a name change in the program. No, we don't intend to do that. We have not, it's a new program, so it's not like we have a decade's worth of people out there with this degree. We aren't changing it. Somebody's asking the question about a 3-unit 559, and if they need 1 more unit to fill up the requirement. For the degree Professor Jenkins could correct me if I'm wrong, but for the degree program, having credit for taking 559, if you've taken the 3-unit version of 559, that counts as taking 559. But
yes, that's
there's
right.
a 32-unit degree requirement for the new version of the degree. So you would have to count something else towards that. And you're asking about seminars. So you're getting a little bit into too much into the details to handle in an open forum. So I suggest you arrange to talk with Professor Jenkins, and he can work you through these details. You know, we had a transition program when we put in the proposal for the degree, but you know, there's no way the combinatorics of all the cases that you guys can create, we can't anticipate them all. So we'll just use our best judgment and try to be flexible and use common sense.
One thing I'd like to point out is for anybody who's currently, admitted to USC, started this fall, whether you're admitted to machine learning or you're in MSCE and thinking about switching to machine learning, if you change your major or are in the machine learning for this year, your degree program is 28 units and the catalog for this year is what you would be abiding to. Next year, with the proposal plan to be approved, there will be some new courses added to that program. It will balloon to 32 units, but you can stay in your 28 unit program. We will still consider if you take some of the new courses that aren't in this year's catalog, and we can apply those as technical electives to the 28 unit program. I think, does that make sense, Professor Chuggin-Jenkins?
Yes, that's right.
So I think they want to explain that there will be some changes in and then so that you're aware of what courses to anticipate that don't show up in the catalog or on the schedule of classes this academic year, but will be there as options next academic year. So you can remain in your current catalog year of machine learning for 28 units, but you'll have a couple more options of classes to choose from that we can slot in as technical electives or software. So just work with your advisor and we can make it work. Hopefully that helps clear up any confusion I would think one might have.
Yes, okay, I can see the chats now. So one person asked, can I ask which of these new courses would be offered next semester? And Professor Chugg answered, relating to some of them, I can answer. I mentioned EE 559 will be offered in this new version in the spring. And now the 2-unit software, one of them I think will be offered, but I'm not sure whether it's going to be the 547A or the 547B. That's maybe yet to be determined. And in terms of deep learning, yes, we would definitely like to see one of the 2 unit classes offered at least. Again, we're not sure yet which one though, I guess, huh?
Yeah, I'm not sure which are going to be offered. I'm not sure if deep learning will be offered in the fall, in the spring. I'm hoping that we can offer software, the second software class, since some of you are taking the first software class now, or the first software class. Part of it is getting coverage by instructors. But we've taught the deep learning in the spring and the fall, and so we may wait until the fall to teach the 541, the first one.
Oh yeah, that makes sense.
Somebody asked about passing 483, will that show on your transcript? And I answered no, other than, the degree requires proficiency in it. So, the fact that you get the degree would demonstrate that. Somebody else asked about the 4 units that are left unspecified in the new degree program, that they just wanted to confirm that those come from technical electives, and that's true, right?
Yes.
Yeah. Any other questions? Another point, like on 567, CS 567, it doesn't require 510 and 503. So, I mean,
That's true.
I think the way that Professor Jenkins described it is pretty accurate. And culturally, between EE and CS, it's the ECEs culturally. I mean, I don't want to stereotype too much, but we tend to want to know how things work under the hood and understand some of just the foundational concepts. And the CS is very effective at abstracting away some of that and working with packages and tools to do a little bit more system integration. So we recognize that the world is changing and that that's an important skill that CS is offering. And so that's has a lot to do with why I started offering the deep learning class, and also with the new software classes that we're offering, is to give you some of that. We're trying to combine the good things that we like about ECE, which is knowing the core concepts and understanding what underlies all of this stuff, with the good things from the CS world, which is making sure you know how to do things in practice. That's what we're trying to do.
Hi, Professor Jenkins. I have a question about the application of artificial intelligence. You know, there are lots of it, like or autonomous driving and natural language processing. I was wondering which field has the potential to develop.
To like develop more and expand more, you mean?
Yeah. In other words, which field has will have the virtual product to promote to the mass market?
Well, if you could answer that with certainty, you could make yourself $1 billion by investing in the right places. So no one knows for sure. But I think any area where there's a big need, and you see machine learning making, and AI more generally making substantial gains and actually coming out with useful things, I think is a good bet. Autonomous vehicles, I mean, there's a huge need, a huge market for them. They are coming. The only thing that is a big unknown is when and to what degree. In 2 or 3 years, what stage will they be at? And another 2 or 3 years after that, what stage will they be at? That's where the unknown element is. But there's a big need and a big market, and a lot of technology that eventually will get where people want. And I think that's true for a lot of the different areas that you see from machine learning and AI. So, I don't think there's any one area that everyone agrees this is the area to go into for the next 5 or 10 years. There are a lot of areas that are just expanding, and probably a lot of them will keep expanding. So that's about all I can say.
Thank you.
Yeah, I think just to expand a little bit on that, a lot of times when your student's coming to do a master's degree, and I don't blame you for this, but you think in terms of like, what do I study to get a job? And oftentimes the faculty are thinking a little differently, and you may be thinking a little differently 10 years down the line. It's important to get a framework for thinking about subjects and thinking about topic areas and thinking just in general, problem solving, that will last you a career and allow you to learn new things as new things come online. So I think in 10 years, things may be quite different than they are today. Currently, the 2 areas you mentioned are huge. Reinforcement learning for autonomous systems, huge hot area, and natural language processing. For those of you that follow Twitter, blogs, and so forth, you may have seen GPT-3 released recently by OpenAI is a 100 billion parameter language model that is coming close to human level interactivity and understanding. At least, if you're having a conversation with it, it's almost as it's reaching close to the Turing limit, the Turing test. So, right now, in terms of like brute force, model size, and complexity, natural language processing is driving a lot of the research. And in terms of understanding how, say, neural networks work, the autonomous systems and deep reinforcement learning is driving that, because we're starting to put these data-driven machine learning devices in critical systems, safety critical systems, and we want to understand, how do they fail, and can somebody hack them and make them fail? And so those are some of the concepts that are really getting a lot of focus in the research community right now.
Okay, well, I see it's 5 o'clock, and looks like the questions are getting more infrequent. So why don't we call it quits here? I might add that I have office hours, and Professor Chugs does as well. I just realized my office hours actually aren't up on the department website yet, but I'll do that today or tomorrow. But in any case, they are Tuesday, Thursday, 4 o'clock to 5 o'clock in the afternoon. And I'll also put a link on the department website for those that aren't taking my class. And feel free to come to talk to me on Zoom or send an email if you have further questions.
So somebody else was asking about taking 483, 503, 510. I would say that many students would probably consider that a pretty heavy load. We are going to have some sample programs with the new degree program. And for somebody who didn't pass out of 483, a reasonable path might be to take 503, 510, and then the 2-unit deep learning introduction class or the 2-unit software A class. And then after that, for example, you could take 483 in parallel to 559 as 2 required classes in your second semester. But the students will have better insight probably on the perceived difficulty of taking those classes in parallel.
Yes, I think that's a very good point. In fact, you want to get EE 503 and 510 taken as soon as possible, ideally your first semester. EE 483 is not so crucial to have the first semester because it's not a prerequisite for as many other classes. So second semester is fine. Even your third semester is okay for EE 483.
Great. Well, thank you, Professor Jenkins and Professor Chugh, for spending the last hour going over the degree requirements, and for all of you who tuned in and asked questions. We are doing a recording of this, and we will disperse that afterward, so you can go back and revisit things. But please don't hesitate to reach out to the professors, myself, or your advisor if you've got any other questions. But wish you all a pleasant Monday afternoon. Thank you.
Thank you, Samantha.
Thank you.
Bye-bye.